This is the third in a series of 3 podcasts that looks at language development and the brain. In the first podcast, we looked at the work of the empiricists Skinner and Bandura, and the nativists Chomsky and Pinker, who all sought to explain the pace and extent of children's language development. In the second podcast, we started to look at some of the brain research in this field. We looked at the 19th century ideas of Broca and Wernicke, and their realization that quite a lot of language processing seems to take place in the left temporal region of the brain. We also looked at the way in which the brain processes phonemes, the smallest units of language. We saw that young babies are actively engaged in the processing of these units of sound, what is known as categorical speech perception, and that it is this which helps them to develop the ability to hear and later to speak the sounds of the languages they hear around them. In this podcast, we will look at some experiments that show the time limits that exist around infants' ability to process and identify new language sounds, and also learn a little bit more about how they learn these sounds, with an emphasis on the work of Patricia Kuhl and her colleagues. The perceptual magnet effect. You will recall from podcast 2 the work of Peter Emus and his colleagues, which showed that babies are able to distinguish between the sounds of P and B, and that, like adults, they will put these sounds into one of 2 categories. Patricia Kuhl and her colleagues have looked at some aspects of how this happens and also the time frame in which it occurs. Kuhl has identified what she calls the perceptual magnet effect. Her work has shown that when we listen to language, there is something like a magnet at work, pulling our perception of a sound to one of the categories of language which we already have stored in our brains. Sounds that are similar to, but not quite the same as the P phoneme will be heard as a P, while those sounds that are similar to, but not quite the same as a B, will be heard as a B. It's like a slightly over-keen filing system that insists that everything has to go into one of the files, even if it's a little different to the things that are already in there. Of course, they can only be a little bit different, and not a lot different. If they're very different, then the sounds simply won't be filed. It does not work when we are listening to the sounds in a language we do not understand. We know that infants learn the phonemes used in their native language very quickly, but that at the same time, they also lose the ability to distinguish between the phonemes that are used in other languages. The perceptual magnet effect, alongside categorical speech perception, acts like a filter, changing what we hear. And this filter works differently for children who are learning to speak different languages. After the age of about 6 months, infants in China or Russia who are learning to speak their native languages will apply a filter to the sounds in their language, letting through the native sounds but not processing others. This process of learning to categorize, filter, and sort the sounds in the languages that infants hear spoken around them means that they also start to lose their ability to hear the distinctions between sounds in other languages which are not heard. Up to the age of about 6 months, infants show sensitivity to sounds in all languages of the world. From about 6 months to 11 months, this universality disappears, so that by the end of the first year, infants are only sensitive to the sounds in their own language. This means that as we get older, we're simply unable to distinguish phonemes that are not part of our native language. The most well-known example to both English and American speakers will be the difficulties that Japanese speakers have distinguishing the r and the l sounds in words such as rake and lake. There is further work that Kuhl and her colleagues have undertaken that looks at whether or not this ability to distinguish phonemes from other languages can be modified. We discuss this in more detail in our book, Child Development and the Brain. You can also hear Patricia Kuhl herself describing her work in her TED Talk. And I've included a summary of the main points she makes on slide 7. In her work, Kuhl has shown that children aged around 9 months are able to quite quickly learn to discriminate the phoneme sounds within a language that they have not heard before. This is achieved by exposing children to the sounds of that language for short periods of time over a number of weeks. The other surprising finding from Kuhl's work is that this only works if the language is spoken by real, live human beings. Children who were only exposed to video recordings of the language being spoken did not learn to hear the distinctive phonemes of that language. It seems that to learn to distinguish these sounds requires real human beings and real human interaction. Just watching it on television simply does not work. There are some important lessons to be learned from this work. First of all, it shows that infants have an astonishing capacity to learn the sounds of other languages. While there might be a decline in the ability of young infants after 6 months to discriminate between their native language and other languages, Kuhl's work with slightly older children shows that this decline can be reversed. It also shows that if we want to be really fluent in the language, then the earlier we start, the better. Work on the way in which we're able to discriminate the sound of our own language from the other sounds of other languages is really important. We now know that if we're exposed to a second language before the end of the first year of life, then we will develop an ability to discriminate the sounds of phonemes which are unique to that language. Yet we also know that this plasticity does not completely disappear. There have even been experiments with older children aged 3 to 6, which have shown that even quite short but fairly intensive emotion in non-native language can lead to them being able to discriminate non-native speech sounds. As Kuhl and her colleagues discuss, this work tells us something about the ways in which young infants learn. It also shows that learning is a hugely intersocial human activity. Being engaged with another human being means there is a lot of interaction. The infant following the gaze of the adult and child both looking at the same object, the adult giving that object a name, and so establishing a link between language and objects. If young infants are to learn successfully, then they need to be stimulated by real, live human beings. Here's a summary of what we've done in podcast 3. We've looked here at the perceptual magnet effect and the way it helps us to categorize language. We've looked at the sensitivity that young infants have to language. We've looked at ways in which this sensitivity can be extended beyond the first 6 months. And we've also discussed how we need real human beings in order to learn language. If you'd like to know more about this and other neuroscience-related subjects, then please have a look at our book, Child Development and the Brain.